Factoring by grouping with a greatest common factor really isn't any different than factoring by grouping that you learned about previously in this lesson. We just have to alter our first step. Instead of diving right into grouping, we want to check our polynomial to see if there is a greatest common factor among all of the terms first. So step one is going to be to factor a GCF, or greatest common factor, from all of the terms if possible. Looking at my 4-term polynomial here, I want to check and see if there is a common factor between all 4 terms. 6n cubed, negative 9n squared, 6n, and negative 9. We should see that there is a common factor of 3 amongst all of these terms. Therefore, we will divide each of these terms by 3. Taking out the greatest common factor of 3 leaves me with 6n cubed divided by 3 makes 2n cubed. Negative 9n squared divided by 3 gives me negative 3n squared. 6n divided by 3 gives me a positive 2n. And finally, negative 9 divided by 3 gives us negative 3. We are now going to complete grouping with the remaining 4 terms of the polynomial. Just like previously, we are going to group the first 2 terms and factor out a GCF. So if I group together 2n cubed and negative 3n squared, I can factor out a greatest common factor of n squared. I'm going to write the original 3 that was my greatest common factor, and I'm going to insert a new grouping symbol to separate my greatest common factor from the grouping problem I'm currently working on. We decided that the greatest common factor of this group was n squared. When we divide, 2n cubed divided by n squared leaves us with 2n. Negative 3n squared divided by n squared leaves us with negative 3. We are now going to group the second 2 terms together and factor out a GCF. Looking at that second group, 2n and negative 3, their greatest common factor is 1. Showing that positive 1 is our greatest common factor, when we divide, 2n divided by 1 is 2n, and negative 3 divided by 1 is negative 3. We previously learned that we have a checkpoint here. We can check and make sure that we are on the right track. We do this by making sure that our parentheses, spelled that wrong, match. As we look over here, we see that this parenthesis of 2n minus 3 does in fact match that parenthesis of 2n minus 3. So we are now going to factor out the common parentheses, which in this case is 2n minus 3. And what's left over is our n squared plus 1. We don't want to forget to include our GCF from step number 1, so we need to make sure that we write this original 3 down in front. So our final factored form is that we have 3 times 2n minus 3 times n squared plus 1. And remember, the order in which we write our parentheses doesn't matter. This would be the same thing as saying 3 times n squared plus 1 times 2n minus 3, because multiplication is commutative. Let's try a second example. Step 1, we want to factor out a GCF, if there is one, from all terms. Taking a look at all terms here, we see that they do not all share an x, but perhaps there is a number that they all share in common. Thinking about a number that goes into 30, 42, 50, and 70, the greatest common factor here is 2. So we will divide each of these terms by 2. 30x cubed divided by 2 gives us 15x cubed. 42x squared divided by 2 leaves us with 21x squared. Negative 50x divided by 2 is negative 25x. And finally, negative 70 divided by 2 is negative 35. The next step, we want to group the first two terms and factor out a greatest common factor. The greatest common factor of 15x cubed and 21x squared is 3x squared. So keeping the original 2, I'm going to introduce a grouping symbol to separate the GCF from the grouping problem I'm now working on. And I'm going to show that the greatest common factor of that group was 3x squared. When I divide that out, 15 divided by 3 is 5, and x cubed divided by x squared is x. 21 divided by 3 is 7, and x squared divided by x squared cancels. We will now find the greatest common factor of the second group. Remember that if the front sign is negative in our group, then we want to make sure we factor out a negative. The greatest common factor here would be negative 5. And when we divide, negative 25x divided by negative 5 is 5x, and negative 35 divided by negative 5 is positive 7. At this point, we are going to factor out the common factor because we see that what's in our parentheses does in fact match. So 5x plus 7 is one factor. 3x squared minus 5 is the other. And then we just need to make sure that we include our original GCF. So 2 times 5x plus 7 times 3x squared minus 5 is our factored form. A final example, we want to start by looking for a greatest common factor among all of the terms. I don't have a variable that they all share in common, but I do see that each of these terms is divisible by the number 4. So 4 times, when we divide 24x cubed divided by 4 gives us 6x cubed. Negative 96x squared divided by 4 leaves me with negative 24x squared. 4x divided by 4 is just 1x. And negative 16 divided by 4 is 4. Now that we've taken out the greatest common factor, we have 4 terms left over, meaning we want to group the first 2 terms and take out their greatest common factor. So we'll write down the original 4. Again, I introduce a new grouping symbol to separate the GCF from the grouping I'm working on. And the greatest common factor between 6x cubed and negative 24x squared is 6x squared. So writing that down, 6x cubed divided by 6x squared leaves me with just x, and negative 24x squared divided by 6x squared leaves us with negative 4. Taking a look at our second group, the greatest common factor between x and negative 4 is a positive 1. So x divided by 1 is x, and negative 4 divided by 1 is negative 4. Right. At this point, we're going to make sure that our parentheses match, and they do. And so we're going to factor out that common parentheses. My common parentheses is x minus 4. What's going to go as my other factor is the 6x squared plus 1. And then I want to make sure that I include the original greatest common factor as part of my factored form. Therefore, 4 times x minus 4 times 6x squared plus 1 is the factored form. You try number 9 and number 10.